Today we're talking about exponential and logarithmic equations. You've done a lot of base work. Now we are going to use it all. So our objectives today are to solve exponential and logarithmic equations, and we're actually not going to do inequalities. We're going to solve problems involving exponential and logarithmic equations. Our vocabulary is exponential equation and logarithmic equation. Not a big deal. Okay, an exponential equation is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, you need these two things are both very important. You're going to try to write equations so that the bases are the same. If you have b to the x is equal to b to the y, then you can just flat out say x equals y. And if you have a equals b, then log of a equals log of b. So basically, if you have 3 to the x equal 3 to the x minus 4, let's say 2x minus 4, okay, that's this first one up here. You can just flat out say x equals 2x minus 4, okay, it's a given. So now we could solve for x. Subtract x from one side, add 4 to the other, I get 4 equals x. It's a great way to solve for x. So it's sort of like the 3's are disappearing, but they're really not. Mathematically, it's a solid move. Also, if you have something like, let's say, I don't know, 4 to the 2x is equal to 5 to the, well, I'll just say 5. You don't know what to do with this, you can actually take the log of both sides. Log of 4 to the 2x equals log of 5. Those are both base 10 logs. So it's pretty simple to solve it from there, and we'll do that when we get to our examples. So there's two things that we're learning today. If b to the x equals b to the y, the b's in a sense disappear, and it's just x equals y. And then if you have two things equal to each other, and especially if there's an exponent in the, or a variable in the exponential spot, you can take the log of both sides and solve for it. Let's get through some examples. Okay, example 1, solve and check. I don't know what to do. I've got a 9 raised to the 8 minus x and a 27 raised to the x minus 3. But that 27 is actually something that I can mess around with. The 9 is something I can mess around with. This is a lot of puzzling again. That 9 is the same as 3 squared. That 8 minus x can't go away. And the 27 is actually the same as 3 cubed. And that x minus 3 can't go away. So now I'm going to have the same base, in a sense, that b, this is that first example, b to the x equals b to the y, therefore x equals y. So I can just say 2 x minus 8 equals 3 x minus 3. Do some distribution, 16 minus, 2x equals 3x minus 9, and solve for x. I'm going to add 2x to this side, gives me 5x, add 9, 15, x equals 3. Sorry, I divided 5, both sides by 5, and got x equals 3. So really not too bad once you realize that you can do that. Okay, you're going to have to really know your numbers. Okay, let's try the next one. Okay, solve and check. Here I have nothing equal, but I can take the log of both sides. Log base 10 of 4 to the x minus 1 equals log base 10 of 5. Remember, base 10s I can do in my calculator. Okay, this is the exponential rule for logs. I can move that x minus 1 over. Log 4 equals log 5. Okay, can't figure out the whole, evaluate log base 10 of 4, but I can divide both sides by log 4. Cancel out. So I have x minus 1 equals log 5 over log 4. Now this is not subtraction of logs. This is get your calculator out and crunch the numbers. Okay, log of 5. Try to keep the numbers in your calculator as much as you can. You'll just have the best success without rounding so much. Log 4. Okay, actually do some division. Okay, this is 1.16. I'm going to add 1 to both sides, and I get x equals 2.16. Okay, you try this one. That 27 can change into a base 3, so go ahead and try to change it. Not too difficult. I changed them both. They both have a base of 3. 3 to the 2x equals 3 to the third. So in essence, the 3's sort of disappear, but not really. And you have 2x equals 3. Try again. So here you're going to take the log of both sides and solve for x. You try this last one. Okay, there you go.